Hi all, welcome back to our program VisionPod. And in the previous video, we took the growth rate. Okay, we find out the growth rate and then we find out the big O notation value. Then here we are always interested finding the growth rate of a function, right? Depends upon the growth rate we are analyze. This is the really it is consuming lot of time or not, it is good or bad, or that kind of things depends upon the growth rate. For this purpose, what we can do, normally we plug in different values of n into a function and plot a graph to see how it grows. So for example, if the value equal to 1, it will plot in the first value. Then if it is 2, then this one 3. So then we connected this one. So then we can find the, or we can get the graph here like this. So this is linear, right? That means linearly depends upon the number of the time also increasing. That means the time complexity is increasing. It is a worst case. So, but why need to do this? So it is really time consuming, right? We get the value and plot in a graph and identify the growth rate. It is really time consuming. Then how we can get it fastly? So that is the another question. Without plotting the values in a graph, how we can find? For example, if you see the program, how we can know the time complexity of the program will be this one. So this is the worst case and this is the best case. How we can identify? So that we'll discuss in the next page. So you can see here, right? You can see here, let's say we are comparing two data structure in a particular operation. So it might be possible some set of input first data structure give you the better result, and some other set of input the second data structure will give you the another better result. That means, for example, in the case of array we are taking array and linked list. So the first case, if the value equal to 1, then we can use array. There is not much. If want to insert the array into the first element, only 2 element is there. We need to add the first one element to the first position. That time only need to move only one number. So that time we can use array. But if the number is more, if the input is n equal to more, then what we can use the linked list, right? So that we discussed in the previous video. You can see here. So it is the better solution is the linked list. So this is already we discussed in the first video. So that is a one case. Then how we can do? That is the another question. So that we can definitely do. I will discuss. The conclusion is we cannot predict that offer which value of n, but we can sure that one data structure will perform better than another. For example, here equal to here f of n and g of n. So if the n is increasing, there is a point. The beyond that point, the function will be growing faster. Okay. But the f of n function is lesser. That means lesser time consuming. That means here, for example, we already discussed about one function in the 3, right? So here in the previous lesson we discussed about for all n greater than 3, that means n greater than 3, the g of value always increasing. That means we get the upper bound. This is the upper bound. This is the beyond 3, that means any number greater than 3, the function is greater. G of n will be the greater, f of n will be the lesser. We have know the value. Okay, so this is the one we can analyze here. If the graph grows faster, the time complexity also fast. That is very important. If the graph grows faster, the time complexity also faster. That means the program is taking more time. It is worst case. So that means the worst time complexity. So this is very important. This is the reason we find the growth rate of the function easily identify the complexity. So that is the main reason we find out the growth rate. Depend upon the growth rate, we can tell that this is the complexity. N is the complexity. It is linearly increasing. If n equal to n square, that means the quadratically it is double, quadratically increasing. So that we can know depends upon the growth rate. So, but there is a problem. But it is a tedious task to plot different values of n and find the growth rate of a function for comparison purpose in a graph, right? Yes, it is a tedious task. Then find the solution. How we can find the solution? So that time the big O notation rescue us. The big O notation help us to finding the growth rate of a function without plotting the values in a graph. No need to plotting the different values of n. Then we will discuss. This is the best part is it gives the least upper bound on the function. So we can set the surety that the function under consideration will never grow faster than the upper bound. Okay. So that means the least upper bound tell us how to worst the algorithm can perform. Least upper bound equal to worst time complexity. So this is the one definitely you want to know. The example. Next example we can discuss here. F of n equal to, for example, I just analyze f of n equal to 5n squared plus 4 and g of n equal to n square. Already I mentioned n square means there is 2 for loop. Here also 2 for loop. That will more time. That is more time consuming. Depends upon our notation. F of n equal to omega of g of n. This is our question. So f of n always less than or equal to c into g of n. Here we can find that 5n square plus 4 less than or equal to n square. So why we give the c equal to 6? Because n square value is 5. So I just incremented 5 plus 1 6. So definitely this will be the greater value as compared to this part. So that's why I give c equal to 6. Need to 1 point greater. So then n square. So solve this one. 4 less than or equal to n square. Then 2 less than or equal to n. That means f of n the function always grow lesser than this one. For all n greater than 2. N greater than 2. That means the input is greater than 2. This f of n function is lesser. So f of n complexity equal to omega of n square. Omega of n square. Never grew faster than the quadratic. It's always never grew faster than quadratic. It will change only quadratic, not cubic. Okay. So that we get from here. Next one. The big O. That means the big O notation simplify the task and eliminate the unnecessary terms. Okay, unnecessary terms. It believes only approximate result. Not actual result, approximate result. So, go back to the page 9 to 10. So, we already discussed here how we can find the approximate value from this graph. We already find it, right? Approximate. Compared to this one, this is huge. So, we can eliminate these values. So, I will discuss about growth rate of standard function. Normally, we are getting log n log n square, n cube, n raised to 4 or n raised to k, anything. So, first example, n equal to 1, 2, 4, 8. This is the order I just mentioned. Anything you can write here. So, log 2 of 1 means 0. Here 1. Log n into log 0, n square 1, 1, 2. So, but this is the first condition. But you can see here, if the n is increasing, this value is higher. So, we can tell that this function is growing faster. N raised to the power of n is faster to growing. This is lesser as compared in the here it is lesser. So, definitely you want to know this thing. For example, I will tell you how we can find the time. So calculate number of n natural number. Normally, as a normal people write this program sum equal to 0 for assigned sum equal to 0, and we take the input from the user. Then for loop is given I in n. Okay, n times it iterate each value adding to the sum, then find the result. But there is a problem. We can see here the first one is assigning the 0. That means 1 unit time taken. and here also input is taken, 1 unit time is taken, but this for loop consume n time. That means it is executing n times. This is 1 time, and also this for loop is n time and this is 1 time, and the print sum equal to 1 time. Actually we are discussing about the statement, okay, that's why we are not discussing this, not n, consider as 1, but already we discussed about n here, so no need to mention. So the total time consuming function f of n equal to n, this n plus 1 2 3 4 plus 4. So this is the total time taken of the entire program, but this is a worst case. So we need to eliminate the constant. You can see here we need to eliminate the constant. So our condition is big O notation, function of f of n less than or equal to c of g of n. So this is the function, just add, because n equal to the n coefficient of n means 1, so here 2n we just consider, this is imaginary one, just consuming less than or equal to n. That means any number, okay, that means any value greater than 4, it will grow linearly. That means n, it will grow linearly. That means the time also high with the input size. This is the worst case. So depend upon the input, it is growing linearly. So this is the worst case. But we already know, the genius know the equation. There's a small shortcut to find out the sum of n natural number. For example, this is the sum of n natural. For example, I want to need the sum of 1, 2, 3, etc. up to 100. So genius know a simple equation. What it? That means this, the last number 100 plus 100 plus 1. That means 101 divided by 2, okay, divided by 2. This will be the sum of the n natural numbers. (100 plus 100 by 2), okay. So this condition will satisfy. There is some more condition there because it is even and odd, that also we need to consider. So we print it here, n into n plus 1 by 2. That means 1 time. This is already executed. There is no for loop and all. Only 1 time it is executing. That means total 3 unit time it took. That means the function of omega of n equal to the constant rate growth. So this is the best solution. Okay. But whatever, for even and odd there is a separate one. But in the print case, only 1 time execute, n into n plus 1 by 2 into 1 time, right? It is executed only 1 time. So what will happen? We know this is a constant, 1 plus 1 plus 1, f of n equal to 3. That means the omega of 1. It is constant, that is considered as 1. This is a constant rate. So this is the best case as compared to we are using a for loop. So still remember this concept, okay? Yes.